Okay, so now we're going to continue our examination of bones and take a look at the anatomy of a typical long bone. Remember, there's short bones, long bones, flat bones, irregular bones, sesamoid bones. And we're going to take a look at the anatomy of a typical long bone, a bone that's longer than it is wide. And this is really a majority of bones in your body. Think of all bones of the arms and legs. Here, maybe not the tarsals, but like the phalanges. So all the bones that make up the toes, the tibia, the fibula, the femur, and then think of anything in the arm. So think of your radius, your ulna, your humerus, all the finger bones. Those are all considered long bones. So quite a few of your bones are long bones. And so I want to kind of focus a little bit on the anatomy of that real quick. So in a typical long bone, we have what we call the tips of the bones. We're not going to call them tips anymore. We're going to call it each one an epiphysis or epiphysis. Remember, the prefix epi means above or upon. So epiphysis represents the tip of the bone. Now, each long bone has two epiphyses. It has an epiphysis that's closer to the body and an epiphysis that's further. So if we wanted to be more specific, we would label this the proximal epiphysis and distal epiphysis. So the epiphysis represents the tip of the bone. The next structure is the diaphysis, often pronounced diaphysis. This represents the shaft of the bone. Okay, the diaphysis is the region between the two epiphyses here. So if we kind of want to take a look here, this represents your diaphysis. Okay. This is the shaft of the bone there. The next one here, we're going to take a look at. I want to take a look at each of. I want to take a look at one of the epiphyses here, and I want to look at something called the epiphyseal line. So, the epiphyseal line is a remnant, and if you think about what the word remnant means, a remnant is like a leftover. Think it's like a leftover or something. Think of a fossil. A fossil is a remnant of an animal that used to live. So the epiphyseal line is a remnant of the growth plates in your limbs. When you grow, and we're going to talk about this in the next slide, bones grow, long bones grow from the tips out. So each epiphysis of a long bone has a band of cartilage called the growth plate. And from this growth plate or epiphyseal plate, it's how we produce new bone. But probably by around age 20 or so, this growth plate closes. That's why we don't get taller after we hit a certain age, okay? And it becomes an epiphyseal line. So essentially, it's your ossified bone growth center. And this this growth plate usually ossifies late teens, early 20s. Epiphyseal line. If you look at a real bone, a real transected bone, you can often find them. They're pretty easy to spot. The next thing is articular cartilage, and this is a layer of hyaline cartilage. Okay. That covers the epiphyses. Okay, I'm gonna make that plural. So when we make epiphyses plural, it's Y-S-E-S. A layer of hyaline cartilage that covers the epiphyses of articulating bones. Articulating means to connect. Articulating long bones. And it is specifically hyaline cartilage. So you can see here's your articular cartilage here. Okay. Your medullary cavity. Now, true for long bones, I'm going to say other bones, but for true for long bones, you do have a space. I'm not going to say our bones are hollow. Our bones aren't hollow, but we do have a space in the center of our long bones, but that space is filled with bone marrow. And we call it the medullary cavity. This is kind of an open cavity in the center of long bones. The medullary cavity is filled with bone marrow. It's filled with bone marrow. It depends on what type of bone marrow based on your age, but it's filled with bone marrow. So this would be your medullary cavity. and would run the entire diaphysis of the bone. So a hollow cavity in the center. I'm going to say in center, but I'm going to put here, I'm going to erase center. I'm going to change that to diaphysis. Open cavity in the diaphysis of long bones. Here we go. Okay. Now, there's two different kinds of bone marrow that can fill these. Yellow bone marrow. Yellow bone marrow is adipose. That's really hard to see. I'm going to go ahead and change that. Okay. Yellow bone marrow is adipose tissue. This is what we have as adults. Red bone marrow. This is essentially bone connective tissue. Well, I'll put here. Red bone marrow is essentially blood cell connective tissue. It can make whatever type of blood cell you need. Red bone marrow is found in the medullary cavity in young adults and children. And found in the cavity of young adults and children. Okay. So in this image, you can tell that this is an older person's bone for two reasons. One, notice the epiphyseal line indicating that the growth plate is fused, which means this person has stopped growing in height. And the presence, of course, of yellow marrow here. Okay. Now, bones are lined with a protective outer covering called the periosteum. And this periosteum is an outer connective tissue layer. Now, technically there's two layers, so I'll hold on to that. But periosteum is an outer protective layer of the bone. It's an outer protective layer surrounding a bone. Okay, an outer protective layer surrounding bone. And the periosteum has two layers. A fibrous layer, this is a connective tissue, abbreviate connective tissue CT. A dense connective tissue layer. This is the more superficial layer. And the fibrous layer actually has protein fibers that actually penetrate the bone tissue. So the fibrous layer here, I'm going to go and highlight that. The fibrous layer is a connective tissue layer that's more superficial, and it contains protein fibers. You can see those right here. We call these perforating fibers. All those little protein fibers, you can see them in here. It contains these protein fibers that penetrate the bone tissue to help really kind of anchor the periosteum into the bones. You can't just rip the periosteum off of a bone like pulling a piece of tape off a table. It doesn't work that way because these collagen proteins literally extend from the tissue and they work themselves into the osseous tissue to make it almost impossible to pull the periosteum off the bone. And we call these protein fibers that do that, we call these perforating fibers. We call those perforating fibers. Okay. That's the outer layer. The second layer is called an osteogenic layer. Okay. This is a cell layer. The osteogenic layer is a cellular layer consisting of osteoblasts. It's a layer of osteoblast and osteoprogenitor cells. Once again, you can see here's your fibrous layer here. And here would be your cellular or osteogenic layer consisting of a layer of those cuboidal osteoblast cells. The endosteum is a thin layer lining the medullary cavity. Lining the medullary cavity and the diaphysis. And lining the trabeculae of the spongy bone and the epiphyses. So endosteum is a thin layer lining the medullary cavity and the diaphysis and lining the trabeculae of spongy bone and the epiphysis. So if we take a look here, I'm going to come back to this, but if we expand on this image here, actually I can just use it right here. They're not showing this to you, but I'm going to use a different color here. Let me use this one. So your endosteum here would be lining this cavity here, but it would also be lining, it's going to be hard to draw, but it would also be lining all these open spaces here. Okay, it would be lining, but it would also be lining all the open spaces of your spongy bone. So all these open spaces would have a lining of endosteum on them. It's going to be really hard to see unless you zoom in to see that. Okay, here's a close look at the endosteum here. You can see the endosteum consists of different types of cells. It consists of osteoblasts. Okay, it consists of osteoblast cells, number one. It consists of osteoprogenitor cells, number two. And you can see that it even consists of osteoclasts. So primarily osteoblasts, these progenitor cells, and then also these kind of like, well, they're essentially modified epithelial cells, but they are contain osteoblasts, progenitor cells, and osteoclasts. You can see those there. That's your endosteum. So that kind of represents the anatomy of a typical long bone. I want to talk a little bit about bone growth now. So there's a couple different types of bone growth. What we call interstitial bone growth. In interstitial bone growth, bones grow longer. In interstitial growth, bones grow longer. So let's take a look at what's happening here. So we're going to start out from the very beginning here. We're going to start out when you're a fetus here, and there's not much to write down because this graph pretty much says everything I need to say. So you start off here as a fetus, and when you're a fetus, prior to ossification, so probably 4 to 5 weeks, you have two main types of bone development. You have what we call interstitial bone growth or interstitial bone development, and we call endochondral development. So we have types of bone growth, and so you have interstitial bone growth, and actually I put growth, but really this is also development here. You have interstitial bone development, and this essentially is what we find in long bones. So this is how we grow long bones. So here you have your little fetal cartilage bones. So this is going to be bones of the arms and the legs, and you start out with a hyaline cartilage model. And then what happens in here is you start to form an ossification center. That's a sexy word to say, a bone development center. An ossification center, okay, forms in the center of the bone. And what that does, what an ossification center does, is it's going to convert the hyaline cartilage into bone. Now, as your bones get bigger and bigger and bigger, okay, is you're then going to start to form, your ossification center is going to continue to develop, and you can see this is going to form the diaphysis of your bone here. Then what starts to happen here, now of course now you're born, you're a little cute baby, and what you do is you start to, most of the shaft of your bone here ossifies and becomes the main developing compact bone. But what happens next is a secondary ossification center forms in the epiphyses. In other words, you form your growth plates. These are your growth plates, and they're going to remain active until you're in your late teens, early 20s. We call these secondary ossification centers. These become your epiphyseal or growth plates. Here you can see it's a young bone here. We have an active epiphyseal plate. What growth plates are is they're a thick band of hyaline cartilage. That forms new bones. It forms new bone tissue. And you will continue to grow bone tissue from these epiphyseal plates. You'll continue to grow and grow. Your bones will get longer and longer from the tips outward until eventually what happens is in this last stage here, and this usually happens in your early 20s. And what happens, your epiphyseal plates ossify, which means the hyaline cartilage gets turned into osseous tissue or bone tissue. Well, once you ossify your cartilage growth plates, your bones can't grow any longer. And so you're not going to get any taller anymore because your growth plates are fused. Okay, and then of course this is now going to become an epiphyseal line. Now this is how long bones grow. You have a different type of bone growth in flat bones, and please forgive me, I did forget to kind of mention this. I want to take this down, and I want to bring an arrow kind of down to here, and I just want to kind of skip this. We're going to kind of go down to here, and I want to talk about the growth of flat bones. Okay, growth and development of flat, short, and irregular bones. Now this is, I don't have an image for you on this one, but this is pretty interesting how it develops. So the first thing that happens here with this type of bone, okay, is number one, you get a, you get actually, essentially, you get two layers of connective tissue. You kind of get two layers here and here of connective tissue. There's like going to be mesenchyme. Okay, this is going to be a mesenchyme here. And then you start to get an ossification center in here. And then over time, your bone's going to continue to develop between these two layers. Now, this is this mesenchyme is kind of like remember, it's a stem cell connective tissue. You're going to continue to form. You're going to form spongy bone here first, okay, and then you're going to continue to form your bones. I should have made that arrow a little shorter. You're going to form. We kind of take a look. You're going to have spongy bone here. That's going to be your spongy bone. Okay. And then what happens is you start to form compact bone on either side of it, kind of on the top and the bottom of the bone. Undo. You're going to start to form on either side here compact bone. So you develop, you start to form your spongy bone. Okay. You begin spongy bone formation here. Okay. That's the first thing you start doing. And then you're going to go ahead and you're going to form some compact bone. And then bone development is finished here. Is you have your spongy bone in the middle. You have your compact bone here on either side. And then the very last step here is this mesenchyme tissue originally here. Okay, this mesenchyme tissue, okay, turns into dense connective tissue and it becomes your periosteum. So here's your P for periosteum, C for compact bone, and S for spongy bone. That's kind of the typical anatomy of how these bones are formed. So think about in a long bone, you have a whole outer layer of long bone. The whole outer layer is always compact bone because it's more rigid. And then you have this kind of center, if you look at long bones here, this is a flat bone, how a flat bone would be made. If you look at a typical long bone here, you see you always have a layer of, this is always compact bone here. We'll use the same colors. This is all compact bone. The outermost portion of bone is all compact. And then here in the epiphysis, you have the formation of this spongy bone. So this would be all spongy bone in here, and you would have that on both ends, okay? All spongy bone in there. And then of course your periosteum is going to be right on the out here. It's always on the outside. Well, spongy bone anatomy is a little bit different. Remember, you don't have a medullary cavity in spongy bone. Sorry, you don't have a, I apologize. Flat bones, irregular bones, short bones are a little bit different. You don't have a medullary cavity in those types of bones. Instead, the whole center of the bone is dominated by spongy bone. So you get something that looks like this, where you have an outer layer of periosteum, of course, attached to the compact bone, and the middle portion of the bone is spongy bone containing red bone marrow. As a matter of fact, flat bones like your sternum, your ribs, and your hips are one of the few places you retain red bone marrow as an adult. So as you become older, when you're younger, you have red bone marrow in your medullary cavities, you have red bone marrow in all of your spongy bone areas. But as you become an adult, that red bone marrow replaces to yellow bone marrow, which is adipose tissue, providing energy because you're bigger, and also probably providing some cushion because you're larger in size and you'll have more impact on your bones. However, you still have to retain, somewhere you have to keep a red bone marrow, as that serves as a stem tissue for blood cells. So you keep red bone marrow stored in the spongy bones of flat bones, irregular bones, and short bones. Okay. As a matter of fact, if you're going to extract bone marrow from an adult, they often extract it from a large bone of the hip called the ilium bone as part of your pelvis. They can even extract it from the sternum, although that's less likely. They're going to extract it probably from that big ilium bone. They're going to pull it from, they're going to penetrate the compact bone and they're going to pull it right through that spongy bone layer. So that's kind of the growth and development of flat bones. Now, the last thing I want to talk about this is this little diagram here. Let me go ahead and kind of separate out this one here. Okay. This is called appositional growth. This is what happens after you're born. Okay, this appositional growth, I mean, actually technically can happen throughout all life, not just when you're, it happens prenatal and postnatal. Appositional growth is a thickening of the bone. So instead of the bones growing longer, it's a thickening of the bones. It's a thickening of bone tissue. So when you're an infant, you are producing your bone, but as you get older, notice that your osteoblasts are laying down more and more bone. The thickness of your bone is getting thicker and thicker. Your bone density is greatest when you're in your mid to late 20s, okay? So here you have the greatest density of bone. You have your greatest bone density. And I would say in your late 20s probably, and then it's all downhill from there. So enjoy it, guys. So, now a couple of things, I made a little bit of an error. So first off, something I want to just really quickly go over here. So interstitial bone growth is bones grow longer, okay? But this whole process that I've showed you here represents a form of bone growth called endochondral. Okay. We call that endochondral because endo means within, chondral means cartilage. You start with kind of a cartilage model. This type of growth and development I've talked about over here, this type of growth and development here, we call this intramembranous development because you have bone development between two membranes of stem connective tissue. So you have a couple of terms here, and this gets a little confusing. So I might just add a page here real quick because I think that was a little confusing. There's a couple different terms here. I just want to is you have two types of bone development, and I do apologize for some of this confusion here. Okay, you have endochondral, which is how you develop your long bones. And then you have something called intramembranous. And we usually put the word ossification at the end. And this is how we develop flat, short, and some degree irregular bones. Okay. And then you have two terms relating to bone growth, bones actually getting longer. Two terms for bone growth. And I kind of interchanged these and didn't mean to. Number one, we have what we call interstitial growth. Number two, we have what we call appositional growth. Interstitial growth, okay, are the bones becoming longer. Appositional growth, this occurs up until your growth plates fuse. Appositional growth occurs throughout your entire life, and its bones become thicker. The bones become thicker or wider. So a couple of terms relating to bone development and bone growth. So I'm just going to briefly talk a little bit about bone fracture and bone repair. So a little bit about bone fracture first. So bone fracture, of course, is a break in a bone. So the word fracture means damage or break to the bone. There's different types of fractures. You can have an open fracture. Oh my goodness. In an open fracture, the bone break usually penetrates the skin. The bones separate. What we call an open fracture here. Okay. The bones separate. Okay. Often puncturing the skin. In a closed fracture, and what we call a closed fracture, the bone break doesn't penetrate the skin. Okay. You can also get the term hairline fracture, which I know you guys all heard. Hairline fracture is kind of an incomplete fracture, kind of an incomplete or micro fracture of bone. We use the term hairline fracture for that one. So you can have a hairline fracture, an open fracture, and a closed fracture. Now, I'm not going to go over all the different kinds of fractures because there are a lot based on how the bone breaks. But three common fractures are, we call a comminuted fracture. A comminuted fracture, as you can see, is that small bone fragments develop at the fracture site. So you get the development of small bone fragments. Almost like your bone, during the force of the fracture, the bone was crushed. At your fracture site. Crushing a bone. You can, and the next two, transverse and oblique fractures, represent a clean open fracture, a clean fracture where the bone is completely broken through. It could either be open or closed. But in transverse, it's just a completely horizontal fracture of bone. And as the word oblique is a fracture at an angle. Okay, you can put the different here. Your bone fractures at an angle. It fractures at an angle, so you can kind of see the difference. One fracture I don't have listed here, something called a green stick fracture. The reason why I want to mention it here is it's common in children. Because children's bones are still developing and they're still ossifying, there's a lot more organic and protein extracellular matrix in their bones compared to calcium phosphate salt matrix. And in a green stick fracture, because the bones are still soft, because their bones are a little softer, for lack of a better term, I'm going to put that word in parentheses here. The softer bone doesn't completely fracture. Now, you can have complete fractures in children, but this is more common. And it's the reason why they use the word green stick. Imagine you take a dry twig and you snap it, right? Well, the dry twig snaps automatically. The reason I call it a green stick fracture is imagine taking like a stem that's still alive and has green in it and trying to break it. You kind of bend it and you can tear it, but you don't often break it cleanly or snap it in two. We call that a green stick fracture. So that's pretty common in children. Now, regardless of what type of fracture you have here, there's several steps involved in bone fracture repair, and that's what this image is. Okay, let's talk about bone fracture repair. So bone fracture repair occurs in a couple of steps. Number one, I want to remind you, as a quick note here, that bone is very vascular. Bone has an amazing blood supply. That's why it heals so well. So bone is very vascular. So the first thing you have to worry about is you have to form a hematoma. You have to form a blood clot. Sexy word for blood clot, hematoma. And that's because we don't want to bleed out. I mean, is it possible to bleed out from a bone break? Yes, it can be, which is why you want to make sure that you're, hopefully, if things are working, your blood should be clotting, and you should form a thick blood clot at the side of the break. Okay, that prevents further loss of blood. Okay, this will prevent, hopefully, prevents further blood loss. The other thing that helps too is that the periosteum is made of dense connective tissue with really strong protein fibers. So if the bone fractures, there's a chance that the periosteum doesn't rip entirely, which means that the periosteum can almost hold blood in a little bit to some degree. It depends on the break. Now, what's going to start to happen is we're going to have to start to repair the site of the fracture. So the first thing is we start to, cells come in and we start to kind of, we start to erode the hematoma. We start to, the hematoma becomes dissolved. We'll use the word dissolved. Dissolved or broken down. And it's replaced with cartilage. And not just any cartilage, a fibrocartilage. It's replaced with a fibrocartilage, what we call callus. And this fibrocartilage callus is going to keep the bones in place. But remember, cartilage is not as strong as bone, which is why bones have to be in a cast for a really long time, is that this cartilage callus has to ossify. Keep bones together. Now, what starts to happen here is your cartilage begins to ossify. It begins to ossify. The first thing we're going to do is we're going to turn the cartilage into spongy bone. So first we're going to ossify into spongy bone, because spongy bone is an easier and faster way to lay down bone tissue. It's not as structurally complex as compact bone is. So we lay down spongy bone tissue. We ossify the cartilage and turn it into spongy bone tissue. Okay. And we call this a hard callus. Now notice this is still spongy bone. So at this point, your bones are being held together and we replace the fracture site with bone, but you're probably still wearing a cast at this point because we can't just have spongy bone as strong as it is, hold bones together. We need to reform compact bone along the diaphysis or shaft of the bone. And that's what the term is here. The bone is remodeled. The word remodeled means fixed or changed, okay? And essentially what happens is compact bone is going to replace spongy bone along the shaft. Oh, okay. Here, actually, I'm not gonna say that because it's where the fracture is. Along outer edge of fracture site. Number one. Number two, the medullary cavity is reformed. Notice that we didn't have much of a medullary cavity right here. So this, of course, is going to be done by the work of osteoclasts. Osteoclasts are going to come in and they're going to dissolve away all that extra spongy bone tissue that was sitting in what the medullary cavity should be. And by the time you finish this here, you're once again you're going to have your a little bit of extra compact bone. They usually tend to put a little extra there for kind of support. That's how a doctor can look in an x-ray and tell if you've broken a bone before. They can often see extra bone remodeling at fracture sites. And then you still have your inner spongy bone layer. And then of course you have your medullary cavity. And then so this is where your bone remodeling is complete. And this can take weeks. Obviously, you know, this will take weeks. So I'm going to finish up this lecture by going over just a couple quick things related to bone pathology and kind of a little bit of clinical stuff. A couple things about bone tissue. First off, the effects of exercise. Number one, exercise is good for bones to a degree. I mean, yeah, it can things like running can often lead to microfractures and stuff like that, but in general, it's good for bones. There's evidence to suggest that increase in activity, of physical activity, will actually increase osteoblast activity, which means if you put a lot of pressure on bones from working out, that's going to stimulate osteoblast cells to lay down more bone tissue. And probably more collagen repair as well. Okay, so more activity on bones, more osteoblast activity, probably better collagen repair. In terms of the effects of aging, as you age, osteoblast activity becomes less than osteoclast activity. What that means is you start to lose bone density. We call that osteopenia, and it's normal. Now you can get something called osteoporosis. Osteoporosis is kind of a major loss of bone density, and it's kind of like an exaggerated form of osteopenia. It's kind of an exaggerated loss of bone density. You can see here a normal bone versus osteoporotic bone, a lot less bone density. Of course, osteoporosis makes bones more vulnerable to fracture. Osteomyelitis is an infection in bone tissue. It's an infection in bone tissue, usually bacterial or fungal. It's usually bacterial or fungal. If it's untreated, it can cause a decrease of blood supply and it can kill bone. So if untreated, it could lead to bone death. This is why a lot of times if people are having surgeries, especially older people, if they're having like any kind of bone surgeries, hip replacements, knee replacements, they'll often put them on antibiotics even before the surgery begins. They're trying to minimize the risk of getting an infection in here. So if we look here, right here, this is the source of the infection. Notice right here, this little yellow patch. And this patch here, compare that to the healthy bone. Then you'll notice the shadowing represents a loss of bone tissue. This is due to infection. That's a bacteria eating away at your bones. Gross. Another interesting, well, I hate the word interesting, is something called rickets. Rickets has another name, has a sexy name, osteomalacia. Okay. And this is a weakening of bones. Okay. Due to prolonged vitamin D deficiency. It's a weakening of bones due to a prolonged vitamin D deficiency. This is a disease primarily of children. This is found primarily. I mean, if you have adults have it, as if adults have rickets, it's often because they had it untreated as children, primarily in infants and children. And for the most cases, it would simply be vitamin D supplements or something along those lines. And if we were to kind of think about what would this look like, I should have put an x-ray in here, but usually what happens is it causes the bones to almost kind of, bones will almost like bow. Bones can kind of bow in, where your bones can kind of look like this. I'm trying to draw feet. You know what I'm trying to do. They look like this instead of being normal and straight. Okay, so this would be normal. Those would be like normal femurs. And then these would be kind of a femur with rickets. And if you have a chance, look up some x-rays of rickets and you'll kind of see what I mean, what happens. These bones are soft and they don't tend to be super rigid. The next thing I want to talk about is dwarfism. Dwarfism, there's two kinds of dwarfism. And the first type is called pituitary dwarfism. Pituitary dwarfism is a lack of bone growth. Okay. Due to a deficit or a lack of growth hormone, usually as a child. Okay, so pituitary dwarfism is a lack of bone growth due to a deficiency. So individuals are much smaller in size all around. So it affects all bones. Now, that's one type. Another type of dwarfism is called achondroplastic dwarfism. Achondroplasia. Let's take a second first and let's separate this word. Actually, I'm going to rewrite this. Forgive me. I'm going to make it a little bigger because I want to take this word apart. Okay, so A, of course, we know means without. Chondro refers to cartilage. Okay, and plasia means cell development. So if we put these all together, essentially you're not having proper cartilage cell development. So what's happening here? So in achondroplasia, you essentially it essentially prevents cartilage changing to bone, prevents cartilage from ossifying into bone. And this is especially important at the growth plates. This is especially pronounced at epiphyseal plates. So therefore, which is interesting, achondroplasia tends to impact long bones more than the other type. So if you look at this diagram here, it kind of explains that. People with achondroplasia are what we call disproportionate dwarfisms, because what happens is some parts of the body, like the head and the torso, bones of those regions are normal in size. The bone development was fine, but you'll notice that they have some shorter than normal parts of the body, usually arms and legs, because those are made of long bones. And so it's the damage to the growth plates that doesn't cause the bones of the arms and legs to grow to their appropriate length, making the person shorter overall, even if things like the bones of the sternum and the ribs and the skull are the right size, but not the bones of the arms and the legs. We call that achondroplastic dwarfism. In case you're wondering, because I know you are, I believe Tyrion from Game of Thrones it has achondroplasia. It has achondroplasia. The last thing I want to talk to you guys about bone cancer, okay? And of course, we know cancer is out of control growth of cells that can lead to disease. So I want to talk about just the 3 most common types of bone cancer with you just really quickly here. The first type is something called chondrosarcoma. Now the word chondro means cartilage. So this is the formation of cancer in cartilage producing cells. This is cancer in cartilage producing cells. It's the second most common form. It's the second most common form of cancer, of bone cancer. Okay. The next type of cancer is something called Ewing sarcoma here. Ewing sarcoma. And Ewing sarcoma is where you get tumors in the bone or soft tissue. So we're probably thinking like periosteum here, in the bone or soft tissue around bone. Okay. This is more common in children. It usually often begins in legs and pelvis, okay? It could be kind of aggressive, and bones of the pelvis, which we'll learn next week in lab. But it can, if it's left unchecked, it can spread. It can metastasize or spread into places like your lungs or bone marrow. Okay, that's Ewing sarcoma. The last type of bone cancer is called osteosarcoma. This is the most common. Okay, this is the most common type. Okay, and osteosarcoma here, once again, this is it's a bone cancer, but this is an interesting type of cancer. This is a cancer that produces sections of immature bone. So you get a cancer, some of these kind of other bone cells, these kind of like osteoblasts or whatever, and it produces kind of this, I think it's osteoblasts or osteoprogenitors. Anyway, you produce this kind of immature bone that's not fully ossified here. This tends to happen in long bones. This tends to happen in long bones, especially high impact joints like the knee, such as the knee. Okay, that's a very, very common site here. For most of these cancers, prognosis is pretty decent if you're stage 1 or stage 2, like any stage 3. Remember, the higher number the stage, the more the cancer has either spread or it's become more invasive. Relatively decent prognosis, but left unchecked can be very, very dangerous indeed. So different types of bone cancer. We're not going to confuse those with types of blood cancer, which we will, and lymphatic cancer, which we will talk about in later lectures. So that does it for this lecture. Chapter 5, you've completed it. Yay.